Hey everyone, and welcome to The Explainer. Today, we're going to completely rethink pretty much everything you know about how we construct and destruct our built environment. We are all so used to thinking of buildings as these completely permanent, monolithic structures, right? They're born in a giant cloud of dust, and decades later they die in a massive pile of rubble. But what if there's a much smarter, honestly much more elegant way to approach our cities? What if the buildings of the future are actually designed not just to be built, but to be seamlessly unbuilt?
Seriously, just imagine that for a second. Think back to those colorful, interlocking plastic bricks you played with as a kid. You build an epic castle, you play with it, and when you're done, you don't just smash it with a hammer, do you? No, you simply untwist, unsnap, and pull the pieces apart. Every single little brick remains perfectly intact, completely ready to be turned into a spaceship or a race car the very next day. Now imagine applying that exact same playful reversible mechanic to massive, multi-story buildings made of actual steel, glass, and concrete. It sounds totally like science fiction, I know, but it's actually a very real and incredibly necessary strategy for our future.
Okay, let's dive into this, because we really need to look at the macro reality of our current construction habits. The numbers are just staggering. Globally, the building sector consumes between 35 and 45% of all our raw material resources. It uses up to 40% of global energy. And when it comes to waste, get this. Construction and demolition account for over a third of all the waste generated in the European Union alone. We're extracting raw materials at this completely unsustainable rate, we're locking all that embodied energy into our buildings, and then, at the end of their lives, we literally just throw it all away.
To really grasp the shift we need here, let's contrast the two approaches. Think about traditional demolition. It is violent. We use wrecking balls and literal explosives to bring structures down, which creates this massive, chaotic pile of crushed concrete, shattered glass, and twisted metal. It's a giant, mixed-waste nightmare that usually just gets dumped in a landfill. That's the old, linear take, make, throw approach. Now contrast that with reversible disassembly. This is where components elegantly snap apart and can be independently retrieved with zero damage. So instead of a mixed pile of garbage, you get these beautiful, pure fractions of materials. A neat stack of steel beams here, perfectly intact glass panels there, pristine wood over there.
And this brings us to a foundational concept in the circular economy called design for disassembly. Now, this is actually a core pillar of a much broader strategy known as design for longevity. You might naturally think longevity just means building a concrete bunker that stands for 1,000 years. But in the modern world, true longevity isn't just about a building surviving forever in one spot. It's about ensuring that its individual pieces retain their value long after the building's current functional life has ended. If we design a building from day one knowing exactly how it's going to be taken apart, we ensure every beam and panel can be separated right back into its original form without a scratch.
So how do we actually pull this off? How do we make a skyscraper behave like a giant Lego set? Well, the secret sauce is entirely in the joints, the mechanics of reversibility. Instead of pouring wet concrete over steel rebar or using these permanent chemical glues that fuse everything together forever, we use reversible connections. We're talking dry connections, heavy-duty nuts, bolts, and screws that you can simply untwist, or direct connections, which are cleverly designed interlocking parts that just click right into place. The absolutely crucial point here is independence. When you unbolt a connection, those two elements are instantly free from each other. There are no jackhammers required. The components separate smoothly, just like interlocking plastic tubes, totally ready for their next adventure.
All right, moving into section 2, the magic of modularity, where we learn that temporary definitely doesn't mean flimsy.
You know, when most people hear the phrase temporary modular building, they instantly picture a cheap, drafty, kind of sad construction trailer. But we really need to completely shift that mindset, because with proper maintenance, temporary modular buildings last just as long as conventional structures. The word temporary here refers strictly to the time frame of the specific function the building is serving on that particular plot of land. It does not mean the materials are low quality. In fact, these are high-tech, precisely engineered fleets of transportable components that are explicitly designed to withstand being assembled, disassembled, and moved around multiple times.
Let's look at the life cycle of this brilliant business model. First off, high-quality, prefabricated components are rapidly assembled on-site using those reversible connections we just talked about.
Once the building has served its specific purpose, say it's acting as a school while a permanent one is being renovated, or maybe an emergency healthcare facility, it isn't wrecked. Instead, a crew comes in and cleanly disassembles it. Then, those exact components are transported and leased out for a completely new project. There are actually firms operating today, like Vanguard Modular, that do exactly this. They maintain these fleets of used building assemblies, leasing them out over and over again. It is the ultimate circular loop.
Now, what's really interesting about this slide is this timeline right here, 20 years. Because this isn't just theory anymore, it's happening in permanent-looking municipal architecture right now. Take the Brummen Town Hall in the Netherlands. This place was brilliantly designed from the ground up with a predetermined functional lifespan of exactly 20 years in that specific location. Why? Because the municipal borders were expected to shift. So instead of pouring a permanent concrete monolith that would just become useless and have to be demolished in 2 decades, they built this beautiful, fully functional town hall designed entirely for disassembly. When the 20 years are up, the building is just going to be unbolted, packed up, and relocated to serve a completely new community.
But let's zoom out for a second. Let's look at this on a massive, macro scale. You might be wondering, can you do this with something truly colossal? Yes, you absolutely can. Look at the Ras Abu Aboud Stadium, which was built in Qatar for the 2022 FIFA World Cup. We're not talking about a small office or a town hall here. This was an entire world-class sporting arena built with the explicit intention of being taken apart. It was a stadium literally designed to disappear from the skyline the moment the tournament was over.
And this brilliantly illustrates that the whole Lego concept works at an incredible scale. The logistics here are just mind-blowing. The entire structure is fully dismountable. That massive roof overhead, designed to be retrieved as an independent, completely undamaged component. And the 40,000 seats inside the arena, every single one of them was installed using reversible connections so they could be cleanly extracted and shipped off to be used in other sporting venues around the world. We aren't just saving bricks here, folks. We are saving tens of thousands of complex, highly manufactured assets from ever seeing a landfill.
Okay, but as enthusiastic as I am about all this, and I clearly am, we do have to stay grounded. Because the ideal scenario is that at the end of its life, components are systematically taken apart. But the reality? Well, it's highly complex. Over a building's life, ownership transfers multiple times. Decades pass. So by the time a building is actually ready to be retired, the new owners might have completely lost the digital blueprints, the material passports, and the actual instructions on how to take the thing apart. And without that crucial knowledge, even perfectly designed reversible buildings often just end up facing the wrecking ball anyway. It's exactly like having a complex, expensive Lego set, but losing the instruction manual. Eventually, people just give up and throw the pieces in a bin. So we really have to preserve the knowledge just as carefully as we preserve the materials themselves. So why does all of this actually matter to you and me? I want to leave you with this final thought. Take a second and just look around the room you're sitting in right now. Look at the walls, the ceiling, the floorboards, the windows. Where are all those pieces going to be in a century? Will they just be crushed up in some landfill? Or, if we truly embrace the magic of disassembly, could that steel beam above your head eventually become part of a hospital in another city? Could your floorboards be repurposed into a beautiful library for the next generation? The technology and the design principles absolutely exist today to make our buildings as reusable as the toys we grew up with. It's time we start treating our planet's resources with that exact same level of imagination and respect. Thank you so much for joining me for this explainer, and I'll catch you next time as we continue to unpack the incredible ideas shaping our world.